Next Curve.
Hey everyone, welcome to Next Curve's reThink webcast or podcast and our analyst corner. And I'm Leonard Lee, executive analyst at Next Curve. Welcome to this episode of Silicon Futures, where we cover the stuff happening in the semiconductor industry that matter. And let's just kind of throw AI, HPC in there as well, because that seems to be the thing everyone's talking about. And before we get started, please remember to like, subscribe, and share and support the Next Curve reThink podcast. You can find us on YouTube and on Buzzsprout. We'll provide info at the end of this episode. So just stick with us, or just don't skip to the end, but, just stick with us, okay? And you can find the details. And before we get started, in this episode, we are going to be providing a recap of NVIDIA GTC 2024, which just finished yesterday. And it was their first in-person event in 5 years. And joining me is my good buddy, Karl Freund, who, did I pronounce it right again?
You did. You got it right. You're getting the hang of this.
I am getting good. So, my mind is not in degenerative. Well, hold on.
Degenerative AI.
I am a little bit degenerate. But, Karl, you are the founder and principal analyst at Cambrian-AI or Cambrian-AI Research LLC, and he's one of the leading analysts, or the leading analyst covering.
Oh goodness!
Yeah,
thank you.
Putting a lot of pressure on you. Semiconductor.
No pressure at all.
Yeah, on the semiconductor industry, and we're collaborating on this series on AI. And so, how are you doing, sir?
I'm exhausted.
Yeah, I mean, you had
it's been a long week.
Yeah, not only GTC had Cerebras, right?
Yeah, Cerebras.
And
yeah. Went to Synopsys, the users group meeting, which just goes right over my head. But I focus on the AI aspects of CAD, CAE, and that's easy. I can get that.
Yeah, well, there's a lot of stuff happening with AI down even at the EDA tooling level.
Yeah.
So, that's really interesting. But we're going to go ahead.
So it was just great to see Jensen live again. After watching him on video for 4 years, it was great to see him live and interact with him. And,
really? You don't get around much, do you? I see the guy all the time.
Nowadays, yeah. He was at SNUG. He was at the Synopsys users group meeting on stage with the new CEO of Synopsys. So he was there. Yeah. He's everywhere.
Yeah, no, I've seen
Taylor Swift.
2 years now, almost every single conference I go to. But it is good to see that GTC is back live and in person. And so let's start off with, what were your key impressions?
Yeah. Everybody was expecting Blackwell. That wasn't a surprise. What was a surprise to me, I was focused on things that maybe people didn't quite get because it all went by so fast. The performance of Blackwell is really, really good. But we expect that from NVIDIA. Of course, they're going to leapfrog H100. They're going to leapfrog MI300 from AMD. Of course they will. But what really got me was the difference between mixture of expert AI and what we now, 15 months later call traditional AI, GPT-3. GPT-3 turns out, when you do training on GPT-3 or inference processing on GPT-3, it's 90% compute and memory bound, I should say, compute and very memory bound, and only 10% communication bound. Okay.
Yeah.
So the network NVLink's not that busy, but when you switch over to a mixture of experts, and you put an expert on each GPU or spread an expert across multiple GPUs for larger experts, they all have to communicate with each other at every layer of the neural network.
Yeah.
And it switches from a compute-bound problem to a network-bound problem to the extent that while the performance of V100, NVIDIA's claims, we'll find out if these are true or not, goes from 8x on GPT-3 versus H100
Mm-hmm.
to 30x on a mixture of experts.
Mm-hmm. Mm-hmm.
So you think about that.
Yeah.
The competitive advantage 30x gives you on the fastest growing workload on the planet, that's big. I mean, that's really big. It means, imagine you're going to go to the customer, if you're a competitor, and say, well, I can solve that problem too. You just got to buy 30 times as many GPUs.
Yeah. No, that's a really good point. And they did put up some big numbers, as when Jensen got up on stage and he did the unveiling. And I know that, we get pre-briefed. I didn't get pre-briefed on that one. I got pre-briefed on automotive, which didn't get much attention. But it really points out, and this is something that I wrote actually in a post in my key takes, is that it really depends on how they got to that point, because my observation was that there were so many architectural changes and improvements and things that really densified the compute, as well as some significant upgrades in the networking that lent to that, and even at the software layer, right? The NIM stuff, I think, was really more. It didn't have as much to do with what was happening with the Blackwell based systems. But I mean, they introduced water cooling. Even on the power efficiency, or at least on the sustainability front, 1/4 in training, a GPT, mixture of expert model. I think there were significant architectural changes. The big question is, how unique and differentiated are those changes at a system level, where the others can't follow? And I think one of the biggest disadvantages of the other players in the space, whether it's AMD or Intel, is literally this willingness to go in and build the system, build a network, build it, and then providing a reference, But
at the core, it boils down to something as simple as PCIe PHYs, right? The physical digital to analog conversion that puts it on out on the wire.
Yeah,
GPU to GPU, because everybody else, NVIDIA, AMD and Intel and everybody else is using Ethernet to get out, or Mellanox to get out, right? But they're going over a PCIe PHY, and that's very, very slow compared to what NVLink delivers. And so AMD Infinity Fabric, for example, is really good stuff, and Broadcom is building a switch for them, and that's all great, it's wonderful. But as soon as you go from traditional large language models to mixture of expert models, you can't use it. It's too freaking slow. And so, if you're just using a large language model, and most people, I would say today, are just using large language models, 20, 80, 170 billion parameters, great. It can handle it because it's compute bound. It's actually HBM bound.
Right.
But as soon as you go to the mixture of expert models, none of those systems are going to work. And it's not that they can't build systems, right? I mean, Dell and HP and Supermicro, they know how to build systems, but they don't have the PHY on the chip that allows them to do the high-speed, low-latency networking that NVIDIA has. And I think for the next year, until maybe 2 years, until one of these competitors comes up with a better way to interconnect their GPUs or ASICs. And I would not necessarily apply that to Google. Google has their own, fiber optic, which is very expensive, interconnect, and that's kind of different, right? But you can't go buy one. You can only use it on the Google Cloud. That networking thing to me feels like a 3-year advantage that And by the time somebody gets there, NVIDIA's on the moon.
Again, it goes back to this question of how much of an advantage, and is it really 3 years? But then at a system level, we have to really think through what's going on here. And I think you're pointing out a really good perspective that we should have here is figure out in terms of timeline, transitioning to these new step changes in the technologies and the associated performance, figuring out what those are. And I think that at a system level, right? And then I think that gives us a picture of how far ahead NVIDIA is. But yeah, I mean, definitely networking is becoming the key to interconnect now is becoming the key to scaling these systems out, right? And that's a great observation, by the way.
So it's interesting that we got some time with Bill Dally, right? Chief scientist, CTO at NVIDIA. He talked about the future, right? What he's building for the future, what he's imagining for the future.
Yeah.
And we asked him about optical because many of us were disappointed to not see optical interconnects in the NVL72 chassis, right? And he said, look, we can put optical on there and it would cost so much power. He said, you think 120 kilowatts is bad? It would have cost us, get this, 20 more kilowatts power because of the transceivers.
Oh, wow.
Yeah. And it would cost a lot more money too.
See,
and so he's not throwing up his hands and saying optical's not going to work. He's working on it, right? And so I think within the next year or two, you'll see an NVL kind of chassis, the new DGX, right? It's not a box anymore; it's a full rack. I think you'll see that switch to optical, but it may take 3 years. I don't know. He wasn't giving any timeline, but they're working on it. And that's, by the way, that's one of the key differentiators many people don't realize is they've got hundreds of people working for Bill Dally, one of the smartest computer scientists on the planet.
Yeah, yeah.
And they're all PhDs from the top universities, and they're all working with the Metas and the OpenAIs and AWS. They're working with the best, right?
Yeah.
And as well as universities around the world. That creates the potential. And by the way, they make mistakes. And when they do, you just don't hear about it. It doesn't become a product, right?
Yeah, yeah.
But that creates, I think, a durable competitive advantage for NVIDIA.
Yeah. There's no doubt at face value it's pretty stunning, right? And by the way, I want to tell you a funny story. I was at AWS analyst dinner, and I was occupying the head of, one of the seats at the head of the table. I vacated because I was like, hey, I'm an analyst. Somebody important's got to sit at the head of the table. And lo and behold, guess who sits in that seat?
Bill Dally.
Bill. Yeah. And then, several of the AWS AR folks were going, oh, who is this guy? And then they found out who he is. Oh, no. You sit here and you can order a steak. So, yeah, we had some great conversations with him. And, I think definitely by the numbers, by what we're looking at in terms of the incredible densification that they've done, not only on the compute side, but then scaling through some, interconnect advantages that they have now really taken advantage of to take things to the next level. It's pretty daunting, right? For anybody out there that's looking at, and again, I'm going to go back to why I think these guys are able to do this is because they are willing to go out and build that whole system. Going, hey, we're just gonna put the iPhone out there. We're gonna go full stack. And
full stack.
That's
exactly
what they're doing.
That's what they're doing, Leonard. It's got to scare everybody else, right? Not only semiconductor providers, but it goes to the system providers. And now, Dell, for example, has finally produced a DGX class system, right? It's a step ahead of what you can get from everybody else. But now they got to look at this NVL72. If it takes off, and I think it will, and say, oh God, now we've got to go build a rack scale copy of that and be able to sell that. They've got a tough road to hoe. They do.
Not
they
even
really
the rack, entire like the module, right?
Yeah,
rack of racks, and I don't know.
It is.
Yeah, and I think one of the things that really stuck in my mind in our session, the Q&A session with Jensen, was when he mentioned that they're alone, that they're really pioneering a lot of things in this GPU-driven AI HPC. Do I have enough acronyms there with that one? Opportunity, right? And so, in order to stay ahead, they need to channel their vision, and then that goes through design and implementation of the entire system.
Let's just talk about NIMs, because you're on the right point there, Leonard. Is that they're so bold.
Yeah,
and they're not the only one doing NIMs. There's startups that are doing NIMs, which is basically microservices, inferencing microservices, and so forth. Yeah, they're all working on it. But when NVIDIA does it, people listen, and people adopt. And the number of partners they had at launch for NIMs, to me, was quite impressive. Everybody from Cadence and Synopsys, to a lot of healthcare solution providers are now offering. Now, we don't know when they're going to release, right? I mean, they all talk like, you can get it now.
We'll talk about that in a moment.
Yeah, I think NIMS is going to be transformational. It will accelerate, because if you can go from the normal 3 months, I hope everybody understands the problem. The problem is, which GPU are you using? Which version of CUDA are you using? Which language model are you using? At which precision? With which inference server software? I mean, the stack is pretty deep. Yeah. Oh, and so what they do is they package it all together, kind of like they do with the NVIDIA GPU cloud, and they say, we got that. It'll run on any GPU with any version, whatever you need. It's all inside the container, runs in Kubernetes. Just download and go. And it literally takes the problem of deploying an inference server, an inference application from months to days.
Yeah, and I guess the real question is where is it going to have the most utility in expanding their? I hate the term ecosystem, but I'll say it anyways. Their ecosystem, right? Because a lot of and then how it maybe either complements or conflicts with things that the hyperscalers are doing and others, ISVs are doing themselves. So, definitely it's going to have a, let's call it a walled garden acceleration effect for them. Because it is like you said, it's optimized and kind of specific for the NVIDIA stack. But the way I look at it, it's essential, right, for them and their strategy. You can't knock it; it's just what it is. And but in many ways, it serves as a kind of like a framework, that like what you've seen Apple do with their whole software stack. Right. Not marketplace. He didn't talk about marketplace. We're just really talking about, okay, how do we package AI services to make things a little bit more composable, so developers can just kind of plug and play different AI services. They can be Gen AI or non-Gen AI, by the way, folks. Yeah. So let's not think everything. Well, and here's the other thing. When we say AI, it's general.
That's not what we're talking about. We're really talking very specifically. AI.
Right.
We're really talking about a system that was designed specifically for large language, distributed, a mixture of expert large language models. Just that section, right? Mm-hmm. You're not talking about image processing. You're not talking about traditional.
NIMS. That is part of it. So I went to the floor and I talked to folks. about NIMs in pretty good detail. And no, it's for all the AI functions.
Yeah, no, I was referring more to the Blackwell architecture, the Grace Blackwell.
Oh yeah. Absolutely.
Yeah, but you're right. NIMs is very broad.
Yeah,
and you combine NIMs with Omniverse. It's like, wow, how does anybody compete with that? But at least they can compete with that, right? This is not like the Phi problem I was referencing earlier.
Yeah.
This is not something that AMD and Intel cannot replicate themselves if they're willing to spend the money and the time to build that ecosystem and build those containers themselves. And I think they will.
Okay, now that you brought Omniverse into the picture, we'll have to think about it, but I'm inclining to, I'm kind of leaning toward maybe semi-disagreeing with you on certain.
That's fine.
But we don't have time to talk about that. We'll reserve that for another episode. But it is a good point. Omniverse, I think, kind of found its footing. A lot of people, I think, don't really know what Omniverse is. But, I thought Jensen did a really good job of kind of putting OVX, explaining how OVX layer is kind of like the bridge between the DGX and the AXG layer, which is like all the endpoint robotic stuff. So all the, autonomous vehicles, blah, 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 they all sit in the bottom. But it's kind of that bridge that creates sort of a life cycle development and design and operational life cycle for what you can consider an autonomous system, right?
I think you're right, and what I was having a conversation with Synopsys executives, and I asked them, where does Omniverse fit in your strategy? And they said something I thought pretty profound. They said, we're trying to transition the company from an EDA company to a systems digital twin company, right? Systems. That's why they're buying Ansys, right? For the CFD,
for the
CFD expertise, right? And so now they're envisioning a world, and they use 5 years as a time frame, where engineers will be building multi-physics digital simulations of a product instead of worrying just about gates.
Yeah, and so that may actually kind of be a sticking point for NVIDIA because, on the industrial side, you have Siemens. I mean, they kind of dabble with Omniverse, but they have entire systems for quote-unquote digital twinning and all the CAD modeling and all that stuff that they've had for decades. PTC, you name them, right?
Yep.
They have their own environments tools. So this isn't a net new thing for them. But in terms of adopting, USD, OpenUSD, that, ironically, that wasn't even invented by. That's not really a NVIDIA thing. That's a Pixar Apple thing.
Pixar, yeah.
Right. They can adopt that standard and then extend their own platform. So I think that's where Omniverse finds quite a bit of competition and something to think about. This is actually a really good thing to think about, and we don't have time to talk about it now, but I'm gonna write that down in my notes. This is cool. A lot of cool stuff coming out of this conversation. So the other thing. And you mentioned in your article, right? And so, folks, if you want to get like a lowdown of everything that happened in GTC, I'll have mine coming out later. I'm not as quick as Karl. Karl's got like a fast trigger there. The new transformer engine I thought was really cool, where you do like sort of dynamic precision. And I did like a really poor job because actually Bill was explaining it to us, right? So we got like a whole back of the napkin explanation for it. I tried to explain it back to one of the AWS folks, and I just did a complete hack job. It was fun.
It's a hard problem because you're combining the ability, which has to be on the chip, by the way. It's not all software. The chip is actually providing telemetry to this observer precision, and balancing precision and accuracy.
Yeah.
And I've said this before. I don't know if he appreciates it, but Ian Buck, the inventor of CUDA, told me that Transformer Engine was the hardest piece of engineering he's ever undertaken.
No, I wouldn't be surprised at all.
And the competitors just compare flops, right?
Yeah.
But they don't realize that, well, okay, but if I'm using Transformer Engine.
Yeah, or, a floating point or integer.
Because for the audience, if what most people do is they'll try to manually determine which layer of the network can be calculated at what precision. Okay, that's very time consuming and error prone. And what they're doing is in-flight analysis to determine which layer of the network needs to be calculated at which precision. Yeah. And then think about it: if you're going from 16-bit float to 4-bit float, that's a massive 16x performance advantage and power savings if you can do it at lower precision. But if you do it at lower precision and your model diverges, that was not a good calculation to undertake.
Yeah. And so, hey, let's talk about really quickly where you see, sort of I don't know if you spoke to anybody about end market stuff, because I think still one of the biggest questions out on the exhibition hall, especially, were these questions about where are the applications.
Right.
Because look, bottom line, most of these things are, especially for enterprises, are in pilot POC. No question. Anyone who tries to argue otherwise, just go and talk to NVIDIA. Now, one of the things where I think they continue to get tons of traction is in a traditional space for them, which is like research HPC type things. That's not necessarily net new. I'm not sure how much of that is growth. Last quarter, data center comprised something like 83 or 84% of their revenue. And then I think a vast majority of that was Gen AI driven, because, their year-on-year revenues, what we mentioned last time, was it like 400, some ridiculous?
Yeah, it's ridiculous.
Right. But the question is, okay, so all the HP stuff, drug discovery, they've been doing that forever. Stuff on, even on the semiconductor side with generative or AI assisted design, been there for a long time. Just talk to the Synopsys and folks, they'll tell you we've been using AI forever, right? But for the generative AI stuff, that's different, and I think they're still trying to figure out, I think the broader AI community is trying to figure out how do we augment and make a step change in, let's say, drug discovery or weather and all that stuff. But, what was your sense? Because I will start off by, setting, I guess, the conversation at, we're still in the early stages and people still walk around going, we don't really know where the value is going to come from, right?
Yeah, I think for most of the let's just start with the enterprises, right?
Yeah.
And enterprise solutions like drug discovery and so forth. The large language models they're using today will run just fine on an MI300 from AMD.
Yeah.
And they'll run just fine on an H100.
Yeah.
And so I think what NVIDIA is trying to do is say, great, we got that. We're 6 times faster in that space. That's wonderful. But this is where we're going, right?
Yeah. MOE stuff, right?
We're going up to MOE so we can eventually get to AGI. Although they don't talk much about AGI, artificial general intelligence. But if you go to OpenAI, you go to Meta, that's what they're all about. They're all trying to race to get to real artificial general intelligence, which would have a massive impact on society and the workplace and jobs. And that's when people start talking about, well, we got to pay people to not work because there's not going to be any jobs. That's where they're providing the infrastructure for the future. They're not there yet. And Jensen has said publicly that they'll be there in maybe 5 years.
Right.
But most of the world's not there, right? To your point, the real applications that can drive incremental growth revenue, drug discovery and oil and gas and manufacturing and automobiles, all that stuff. I'm not sure they need an NVL72. We'll have to wait and see.
Yeah.
The hyperscalers do because they all want to go to AGI.
Yeah, and what I've, several people have asked, actually a bunch of people asked my take on things from, what we saw with the Blackwell presentations. And, I said, look, one of the greatest things that's happening right now in a very tangible way is how AI supercomputing is just going exponential, because all these innovations that have been put into the Blackwell systems that are kind of tuned or geared toward, like what you're saying, MOEs, those technologies are reusable or can be leveraged in other architectures for different other types of AI applications, right? Those are the great things that are happening, whether it's like, web scale, or what do you call it? Wafer scale engines, Cerebrus, right?
Cerebrus.
Yeah, all of these dynamics that are playing out and chasing this Gen AI rabbit, I think you're going to benefit supercomputing. Period. It just makes them cheaper, more cost efficient, and then expands the field of possibilities. But yeah, the big question mark is with generative AI, can the spend in this be sustained even in the short term? Because this is getting really expensive.
The market thinks so. I mean, NVIDIA is up like 3% today on the Friday after it.
Yeah, but we don't talk about stock price here, and we don't talk about that's for somebody else.
But my point is, a lot of people believe it will be.
Yeah, but we're not about belief either. We're about what's really happening, right? I can care less about what Wall Street guys talk about, and that's not, that's not what we should be talking about on this show.
Okay. Let's talk about. Let's maybe we can do our next call on Cerebrus. That might be an interesting topic.
Yeah, that would be really cool. Because, and maybe talk about what they did with Blackwell, because it's really just two chips stitched together with NVLink, which is probably something really similar to what Apple did with the, Ultra Fusion, right? It's probably exactly that TSMC interconnect technology that they use, but it's a different way of scaling the silicon, right? But I think, you made I don't know if you mentioned this before we hit the record button or after, but it's there is this really compelling potential disruption that Cerebrus is bringing to the table with having these massive. I mean, it has different architectural implications. It creates different possibilities. But NVIDIA, one of the things I thought about the Blackwell chip is, I think they kind of see the writing on the wall.
Yeah, maybe. Right. It's definitely they're the only guys doing it. So, it's kind of like when you watch the high school band march down the field and one guy's got his left foot out and everybody else has got their right foot out. And the mother of the guy with the left foot out will say, well, my son's right. Or my daughter's right. Everybody else is going the other way. So maybe Cerebrus has got their left foot out. But let's spend some time on that when we got a little more time.
Well, so anybody who's interested in listening to that conversation, we're going to be teeing that up. So that's why you have to like, subscribe, and all that nice stuff. And then any final thoughts before we wrap things?
It's a great time to be alive and a great time to be in semiconductors. It's just what they're doing today is fun. It's just shocking. Yeah. What these engineers and scientists are able to achieve these days. It's wonderful to see.
It is. And what about last thing? What would you like to see next?
That wasn't my last thing.
Is it? No. What would you like to see at GTC 2025?
Oh, that's a really good question. I'd like to see evidence of their new product pace, right? And how they're using AI to accelerate the design of semiconductors so they can go to a yearly product space. That's what they've said they're doing. But let's see if they can deliver.
Right. That'll be interesting. Yeah, for me, Next year, I hope they start to talk about security and trust more. It's not just about confidential computing. I thought they really missed out big time. A lot of the stuff can't go out beyond a highly secured, isolated data center unless they can figure out the security part about it. And I mean it holistically. Most specifically, how do you foster and support privacy and confidentiality? Enterprise confidentiality, not just confidential computing. This is stuff that everyone just gets completely screwed up and mixed up. That needs to be really squared away. Otherwise, this stuff is not going to go anywhere. Security is number one. It's not last. Security is that thing that you always bump into that will eventually become a hard no. So
cool.
Hopefully, the folks at NVIDIA and their ecosystem start to address in a material way at GTC. Too many acronyms, Karl. GTC 2025. Yeah. So, let's wrap this up. So,
all right, let's wrap.
Yeah, thanks for joining me in this discussion. Really super fun as always. And why don't you do this very quickly? Tell everybody how they can get in touch with you, and then why don't you plug your article?
Yeah, so my latest article's always on Forbes, but those articles show up on Cambrian-AI.com after 5 days. So if you don't have a Forbes subscription and you can wait 5 days, you can see it on my website. If you can't, you need to follow me on Forbes. That's probably the best way to reach me.
Yeah, that's not a bad thing. It's a good thing. Yeah, and so I want to thank everyone for tuning in, and we're at that point where you can find out how to connect with and just get involved and listen to our podcast on a regular basis. So just please subscribe to the Next Curve YouTube channel, as well as our audio podcast that is on Buzzsprout. You can just go there, look up Next Curve reThink podcast, and then just listen to us on your favorite podcast player. And the other easy thing to do is just subscribe to the Next Curve Research Portal and Media Center at www.next-curve.com for a constant and healthy diet of the tech and industry insights that matter. So, Karl, thanks so much.
Good to talk with you again, Leonard.
Fun.
Good to see you.
All right. See you next time.